Hello, my name is Alexander Jameson, and today I'm going to be presenting the past, present, and future of robotics. Is this part of the future scanning project for my class? All right, so to get us started, we're going to talk a little bit about the very beginning of just what robotics is. So, plainly, just with this definition, an automatically operated machine that carries out a series of actions independently and does that work usually accomplished by a human, right? And that's a very broad definition. There's lots of robots that do lots of different things. You could talk about the robot wars. So you build little robots that fight against each other. Obviously, like on the left picture here, you have humanoid style of robots, and then you also have industrial arms that do its own tasks, right? So robots come in many forms. I just think it's important to understand that there's lots of different ways to look at these things, right? And so we'll go into a little bit more detail later, but I just thought it was important to see the difference in some robots in the very beginning here. Now, let's just talk a little bit about, the different types of robots. We'll get into a little bit deeper the farther we go through this presentation. But just to get us started, I'll talk a little bit about healthcare. There's many different robots in healthcare, everything from surgery assisting robots, which means that there's a robot in the surgery with the doctor, cutting patients open, using lasers, knives, all different kinds of tools, whatever it may be. There's medicine counters, meaning you go up to a robot and tell it what you need, and it will pull out the exact dosage that you need for that patient, have it perfectly ready for the doctor, so that way there's less time spent fiddling around trying to do stuff like that. There's filing robots, which is you just take your papers, you give it to the robot, and it puts them away accordingly, so that way everything is where it should be without any issues. They look a little bit about manufacturing. These are kind of like it says here, the assembly run robots, like you saw in the previous slide with that yellow arm, that industrial arm. Those are the kind of robots that we're talking about here. Is the small move things from one place to another, put things together, kind of like your Henry Ford assembly line. We look a little bit like logistics. This is kind of like your manufacturing, except it's like putting away and bringing out goods, which means like say you're working for like UPS or Amazon in a warehouse, you could give it to a robot and it will go grab the goods off the shelves, bring it to you, and then you have goods now for your customers. Or you can even give it stuff so if you're stacking warehouses, and the robots will go put it in its exact spot without having to be carried or told exactly what to do. Go a little bit about military. There's nothing more in this presentation about military. I just thought it was important to talk about robots in military. And so the example I give us here is Centaur, which is an explosive detection and disposal robot, which does exactly what it says there. You send it into a place that you think might be laced or has explosives in the area. It finds the explosives, picks those up, disposes of them, gets rid of them properly without any human casualties. A little bit about entertainment. This is typically where you see your robots, your toy robots, the Rock'em Sock'em robots, different stuff like that. Even like the little humanoid robots that sit there and will talk to you and play with you and stuff like that. Or you can even look at robot restaurants. Like we've talked about in my class here, we've talked about the restaurant with a flippy robot, which is a robot that will flip burgers, serve burgers, put the burgers together, stuff like that. We'll go into a little bit farther with some other robot restaurants later on in the presentation. And then one of the big ones, in my opinion, is travel, right? These self-driving vehicles that you see from Tesla and more companies nowadays, right? We don't typically see these as robots because, they're cars that we're in control of. However, with these self-driving capabilities, it's completely automated. It drives itself, it detects the areas around you, it makes the turns, it slows down, it speeds up, it does all of that, which is explicitly, if we go back to that first definition, is exactly what it talks about. A self-automated thing that's doing typically what a human should be doing. And these just are some brief types of robots. We'll just keep moving. Now let's talk a little bit about advantages. Obviously, robots can work in hazardous environments, as we saw with the military explanation, right? You're sending bomb or robots sent to defuse bombs and stuff like that. There also could be used in like nuclear power plants, right? So nuclear power plants, there's lots of hazardous material, lots of radiation, stuff like that, especially in these power plants that have, started to collapse in on themselves and are starting to leak out hazardous materials. The use of robots would be a great way in order to use robots as a way to protect human lives and work through these areas without causing any damages to humans, right? You can also look at the cost effective side, right? So robots might be very expensive up front. However, robots don't take sick days. Robots don't need days off. They can work 24/7, 365 with no issues at all, right? There's no, I need to take this day off unless something happens with some kind of maintenance or something like that, which is typically pretty easily fixed. We can also look at the increase in productivity, which is, robots are wired to perform repetitive tasks ad infinitum, which means that robots can do the same task over and over again from now into infinity, right? Obviously, as long as there's power, as long as there's maintenance kept up, as long as you're able to do that, you're able to completely use these robots to do the exact same thing over and over and over again. And with that, you get this better quality assurance, right? So you have these concentration levels. As humans, like we're not wired to do the same task over and over, so we start to lose concentration. You think about what you had for dinner or what you're going to do later that night. Robots don't do that. They stick to exactly what they're wired to do, and they'll do it over and over and over again until they're told to do something different. Otherwise, they will do that task until infinity, or again, and told not to. Now we look at the disadvantages here. So there's obviously, startup costs, as I mentioned before. It's expensive to put these robots in up front, right? There's obviously some, different robots for different tasks that might be cheaper, but overall, to include a robot is a lot of money up front, which usually is a lot of short-term costs. But you know, if the business is successful and you use robots in the right way, you can make a lot of money off robots very easily with saving on, the cost of jobs and stuff like that. Now, as we look at the jobs, right? So obviously, you're going to lose a lot of lower level position jobs that robots will take over. From this, you can kind of look like assembly line jobs, stuff like that, putting stuff together. These very low level blue collar jobs. However, it does open some higher level positions, right? So, as a disadvantage for the company, now that you've lost these blue collar jobs, you paid a lot of money for the robots. The robots are doing their job, right? But now you're having to pay professional support staff to work on these robots, right? So you're paying hundreds of thousands of dollars a year for different people to come in and maintain these robots and keep them updated and repair them and whatever need be, right? But it's something a lot of money that goes into this when it comes to robots. Now we're going to go into a little bit of the ethics of robotics. As we talked about in the previous slide with the disadvantages, there's some issues that come with robots taking jobs away. However, on this slide, I wanted to be very clear that what we see here is not truthful, right? These are ideas that people thought would occur due to robots taking over jobs and the kind of things we might run into, right? So a quote from a very popular article is that there's large and robust negative effects of robots on employment and wages, right? Meaning that you're going to put in these robots that are going to take over jobs and it's going to cause high levels of unemployment, very high wages for the people to work on these robots and stuff like that, which could cost the company a lot of money. It can cost people their jobs, stuff like that. There's this idea that 38% of jobs will be lost to automation by the early 2030s, which, while that may or may not be true, there's still the idea that it's opening other jobs that these automation is covering, right? And so one of the big ideas here is this idea of a robot tax. So during the big thing when robots were quote unquote taking away all the jobs, right? There's this idea that what about all this income tax that the government is losing from having to, from people losing their jobs and robots not doing the jobs, right? So there's this idea of a robot tax. The idea that the lost income from people now would be caused, or you'd be taxing robots, as in you'd be taxing the business, right, for more money in order to make up for that lost income for people not being able to have jobs, right? So there's just different things to think about here when it comes to ethics of robots. However, let's move to the next slide. All right, now when we continue to talk about ethics of robotics, we need to talk about some of the true assumptions compared to what our previous assumptions were, right? So our previous assumptions being that robots are causing, jobs to disappear, and we're going to run into these issues of not being able to pay people. What actually happened is that there was a $71 billion increase in just 2 years of robotics, and almost half of the money that was attributed in that $71 billion increase was for the training of new employees, right? Training of new employees to deploy robots, integrate robots, and consult with robots. But $32 billion that were specifically went to employees, right? Which means that there's more people being paid, and they're being paid out at a higher salary. On top of that, we can look at the study by the International Federation of Robotics, which shows that in China, Japan, Brazil, and India, there's decreased unemployment rates as we found the use of robotics. Meaning that across the world, maybe not the entire world, but in a large majority of places, there's going to be more robots, more jobs, and higher paying salaries instead of low level positions, very low working wages, and very low enjoyment in those working wages would be my guess. But robots are helping to improve society not only by using the technological advances, but also by being able to offer more jobs and give higher pay rates to those people. Now, we're going to talk a little about the history and the past of robotics here. Not going to get anything too crazy, just wanted to make sure we have at least a little bit of a background story here. So in the very beginning, talk about where the word robotics came from. It is based off this word of robota, the Czech term for forced labor, which, I mean, if you think about it, right, you're having an automated system of a robot to do something for you. You're basically forcing it to do it for you. It doesn't have a choice, no matter however, again, they don't have emotions. So being forced and just being told what to do might be the same idea, right? However, these idea of something, working for you automatically is not a new term. It's been around since Aristotle, Leonardo da Vinci, right? And there's been books written about it, this idea from Henry Ford and the assembly line robotics, stuff like that, right? But the word of robots comes from the RUR, Rossum's Universal Robots Check Play in 1921. This is the very first time the word robot was ever used, and to this day, almost 100 years later, over 100 years actually, we still use the word robots to be able to describe this idea of automated tools or something that's automated and doing a human job for you, which is just a very, very interesting statement that I never expected to hear. Now we talked a little bit about the different types of robots from the very beginning. So we had our first robot in 1954. This idea of a hydraulic arm. It just did a very automated task, moving that hydraulic arm up and down. Very simple robot, not a whole lot of artificial intelligence or anything deep into that. We move a little farther into the 60s. You get the more advanced robot arms that are able to move with some more capability, do a few more tasks. In the 1966, we see Shaky Robot. This is the first mobile robot. So instead of just a robot in position that is doing a very specific task, this robot is able to move, whether it's rotating back and forth or moving from one place to another. It's able to do something more advanced, right? In the 1970s, we had the big space race. So you see the Mars rover from NASA, right? This ability to take pictures, be on different planets, move, do whatever it needs to do, right? Which is just a great leap of technology for us in the 70s. In the 80s is when we start to get this idea of artificial intelligence was very complex robots, meaning that things now do stuff automatically. They don't need to be told by a human when to start, when to stop. They can do it on their own. This big boom in automation is what we see in the 80s. And in the 1990s, I just thought this was very interesting here, but we have the IBM Deep Blue. This is an IBM supercomputer that was put up against the master of chess, the number one chess player in the world at the time in the 1990s, and beat that chess player astoundingly fast. It was probably one of the worst losses he's ever had in his life, and it was to the IBM Deep Blue, which is just another way of showing that these robots that we're making here are not only, crazy smart, crazy efficient, right, but they're also able to, move past humans and be way smarter than humans than we ever expected. Now we're going to talk a little bit about robots and manufacturing, just because I think it's important to mention some of these parts here, some of the smaller advancements. So again, in the 54, we had our very first, very limited intelligence, first industrial robot. We move into the 62 year. This is the first use of the industrial robot by a major manufacturer, and it was actually used by General Motors in New Jersey. So another one for the United States. And then we look at the silver arm. Right, this is a new robot that came about, which was still a manufacturing tool, but it was able to put very small parts together. And we're talking, putting small parts in like a radiator or putting like small toys together, something like that. Very small, very hard to use parts. And then a year later, in 1975, we see our first electronically driven robot, which means that all these robots that we've seen previously have been run on engines, whether it be the steam engine, gas powered, whatever it may be, right? But 75, we start to move this way towards electronics, using these electronics to move robots, making them smaller, more capable, stuff like that. 80s, like I said before, this is the idea of artificial intelligence. We have a lot more intelligent, versatile robots, even have starting to use this idea of human intervention and human communication, right? So being able to talk to humans, work without any use of humans, right? Be able to do their own thing, which might lead into some issues later on that we'll talk about. But this idea of complex things all the way to the present is where we're working on currently.